Hey friends, and welcome back to Deep Dive. Have you ever wondered what you would do if you woke up one morning to find a rock from the middle of the galaxy had crashed, right through your roof? Today's story is about exactly that. It's a story about letters from space that sometimes arrive with a deafening roar. Picture this, August 2025. The sky over Australia lights up with a giant blazing fireball. Eyewitnesses said it looked like a molten volcanic rock burning with a searing orange glow, flying even lower than an airplane. The sound was so loud it shook houses to their foundations. Now, let's cut to a few months earlier, in the state of Georgia, in the U.S. Here, there's no giant fireball, just a tiny rock about the size of a cherry tomato that punches a hole through someone's roof, hits the floor, and creates a sonic boom so powerful the neighbors thought it was an earthquake. To this day, the homeowner is still finding bits of space dust in the corners of their house. These two events, one magnificent and terrifying, the other small and personal, are more than just exciting news. They're like postcards sent to us from the depths of the cosmos, and they carry crucial messages that we're going to decode together today. What are these rocks? Where do they come from? And most importantly, what secrets do they hold about the birth of our solar system and about us? First, let's get our terms straight. When a piece of rock is wandering through space, it's called a meteoroid. When that same rock enters Earth's atmosphere and burns up, creating a streak of light. That fiery trail is what we call a meteor. The shooting star we make a wish upon. But if a small piece of that rock manages to survive the fiery journey and land on the ground, its name changes one last time. It becomes a meteorite, a rock we can actually hold in our hands. You might not believe it, but somewhere between 10 and 50 meteorites reach Earth every single day. But since most of our planet is covered by oceans and deserts, the chances of one landing near us are incredibly slim. That's what makes that little cherry-sized rock from Georgia so special. It was only the 27th meteorite ever officially recovered in the entire state. But the most mind-blowing part of this story is the age of that rock. Are you ready for this? It's about 4.5 billion years old. That means this rock is 20 million years older than planet Earth itself. You're looking at something that was floating in space before our world even existed. A true time capsule. By studying these time capsules, scientists are piecing together the story of our solar system's birth. It's like they're reading letters written 4.5 billion years ago. Most of these letters are of a specific type called chondrites. These are like the original recipe for the solar system, raw ingredients that were never melted or changed. Inside, they're filled with tiny, millimeter-sized spheres called chondrules. These chondrules were molten droplets in the primordial cloud of gas and dust, the very place where planets were beginning to form. They flash-froze in an instant, becoming a perfect snapshot of creation. Some of these letters are even older. A meteorite named Murchison, also found in Australia, contained particles that scientists call pre-solar grains. This means these tiny bits of dust formed around other stars that died and exploded billions of years before our own sun even existed. Some of these grains have been dated to be 7 billion years old. We are literally touching the dust of long-dead stars, but not all meteorites are so pristine. Some are fragments of mini-planets or protoplanets that formed in the distant past, melted, and became layered just like Earth, with a metal core, a rocky mantle, and a crust. Cosmic collisions shattered them, and their pieces were scattered across space. The iron meteorites we find are actually the beating, metallic hearts of those lost worlds. And even more amazing, we've found meteorites here on Earth that came from the Moon and even from Mars, rocks that were blasted off the Martian surface by a massive impact, traveled through space for millions of years, and finally landed here. So, these letters from space are poetic and scientific. But what happens if one day, a very, very large letter is addressed to us? This is where the story shifts from science to survival. We've had two major wake-up calls in modern history. One was in 1908 in Tunguska, Siberia, where an object about 50 meters wide exploded in the atmosphere with the force of hundreds of atomic bombs. The blast flattened 2,000 square kilometers of forest. Because it happened in a remote area, there was no human catastrophe. The second alarm was much more recent. In 2013, over Chelyabinsk, Russia, a 20-meter meteorite, about the size of a house, entered the atmosphere without any prior warning. Its explosion released the energy of 30 Hiroshima bombs. The resulting shockwave shattered thousands of windows, injuring more than 1,600 people. Chelyabinsk was a slap across the face, a stark reminder that this threat is very real. And this is where planetary defense comes in. It's not a sci-fi term, it's a coordinated defense comes in. It's not a sci-fi term, it's a coordinated global effort to protect our home. The Planetary Defense Plan has several stages. First, detection. Telescopes on the ground and in space are constantly scanning the sky to identify and track any near-Earth object. We have to find them before they find us. Second, prediction. Once an object is found, supercomputers calculate its trajectory for decades and centuries into the future to see if there's any risk of collision. And the third, most exciting stage, interception. Let's say we find a dangerous asteroid on a collision course with Earth, and we have years of warning. What do we do? In 2022, NASA found an answer. In a mission called DART, they intentionally slammed a spacecraft at high speed into a small asteroid named Dimorphos. The goal wasn't to destroy it, but to see if the impact could slightly alter its path. A game of cosmic billiards. The result was a spectacular success. The collision changed the asteroid's orbit far more than expected. For the first time, we proved that we had the technical ability to deflect a dangerous asteroid. Of course, there are other ideas too, like the gravity tractor, where a heavy spacecraft would fly alongside an asteroid for years, using its own tiny gravitational pull to gently tug it off course. The key to all these methods is time. We need years, preferably decades, of advance warning to do anything. These rocks falling from the sky are a stunning bridge between our deepest past and, perhaps, our most critical future challenge. They are both precious messengers from the dawn of time and a constant reminder that we live in a dynamic, and sometimes violent, solar system. The final question is this. The next time a rock falls from the sky, will it bring with it a secret of creation, or a warning for the future? And more importantly, how ready will we be to receive either message? Thanks for joining us on this cosmic journey. If you enjoyed this video, please give it a like and subscribe to Deep Dive so you don't miss our next story. Our other videos are also full of curious tales you may have never heard. Until next time, take care.